Sorry about that. I accidentally deleted the video in the middle of that problem. So we were just finishing saying there are 10 different teams we could make. So we're going to continue off that basketball problem. If you don't have it, there's the problem. What we decided is now that we know the answer is 10, I want you to understand why that answer is in 10. And to do that, let's relate it to the problem we're already familiar with, right? We are familiar that if you have 5 different people that you're putting in order, 5 members of this team, you then would need to divide by 5 minus 3 factorial, right? Because you only need 3 of them. So, long story short, if this was if order mattered, this is what you might hypothesize is the answer. Now, the problem is 5 factorial over 2 factorial, that answer is going to be 60, and 60, no, I'm sorry. Yes, that answer would be 60. Now, clearly, there are not 60 teams. So the question is, how do I take what I thought might be an answer of 60 and actually get an answer of 10? So if you notice, we're continually building. Well, what it really boils down to is, let's look at one of these teams. This team could have been written ABC. It could have been written ACB. It could have been written BAC. It could have been written BCA. All these teams are the same, right? It could be CAB. It could be CBA. So no matter which one of these teams, right, there are 1, 2, 3, 4, 5, 6 different ways to write each one of these teams, right? And if I take this and I divided it by 6, I would get my answer of 10. Now, the question is, well, where did they come up with this number of 6? And if you think about in probability, you're always using factorial. So I don't actually like to call that 6. I actually prefer that to call that 3 factorial. And if had I done 5 factorial divided by 2 factorial times 3 factorial, and again, that 3 comes from the problem, all right? 3 is the number on the basketball team, so it's a slightly more complicated formula, then I would be able to get my answer of 10. So again, what you're noticing is this formula keeps building. So what we started off with ordering n elements, that was n factorial. Then you had n elements, but you only wanted to order r of them. And order did not matter. Now, when order does matter, this extra r factorial gets added into the denominator. And this combinations notation, this is actually in our calculator. I will show you how to do this in class. But that's our formula, n factorial over n minus r factorial over r factorial. All right, so how many 5-card poker hands are possible from a deck of 52 cards? I hope you're not going to write all of these possibilities out. You might be here till you graduate. So if you do think 52 cards, there are 52 factorial. That's the top of the fraction. There are 52 factorial different ways to order 52 cards. But now we got to start the division. All right. Well, I'm only ordering 5 of them, so 52 minus 5 factorial, 52 minus 5 factorial, and because order doesn't matter, right, the order I get dealt the cards, if they're in a different order, it's still the same hand, I have another 5 factorial on here. So what I'm thinking here is you have 52 times 51 times 50 times 49 times 48. Now, I could write 47 factorial. What's going to happen is on the bottom, I'm not going to write out 47 factorial because I know right away these are going to cancel. But I do need to write out that the rest of that 5 factorial. And again, I told you I prefer to do these by hand because 2 times 5, that's 10. That goes into here 5 times. 4 goes into 48. Let's see, that's going to be 12 times. And 3 goes into 12 4 times. So now all I really need to type into a calculator is 52 times 51 times 5 times 49 times 4. I'll let you do that on your own time to get to the correct answer. If you're going to notice, it is quite a large answer. All right, so last question of the day. Going to combine everything we've learned. You are forming a 12-member Frisbee team from 10 girls and 15 boys. The team that you are forming will consist of having 5 girls on it and 7 boys. How many different 12-member teams are there? All right, so let's break this up into 2 questions first. Let's talk about the girls' team and the boys' team. We're going to do these 2 problems separate. I want to know how many different girls' teams can I come up with? Well, I know there are 10 girls, and I need 5. Right? I have to think to myself, does order matter? The 5 girls, if I take 5 girls and I switch their order around, is it still the same team? It is. So this is that last formula, right? Order doesn't matter. So 10 girls means 10 factorial on the top. All right. I only need to order 5 of them, so that's the 10 minus 5 factorial, and then another 5 factorial because order doesn't matter, so there's even fewer combinations. All right. So what this totals out to is going to be 10 times 9 times 8 times 7 times 6. The 5 factorial is going to cancel everything after that. 5 times 4 times 3 times 2. Let's do 3 times 2 is 6. 5 goes into 10 twice. 4 goes into 8 twice. So that's going to be 4 times 63. 200. 4 times 63. 272. Sorry about that. We're going to count that 252. All right, and you know it's going to be so that's the girl. There are 252 possible girls teams. Let's work on the boys teams. From the boys, I had 15 boys to start, but I only need 7. Okay, so what's this going to look like in terms of a combination? Well, I have 15. I'm going to order 15 boys. I'm going to have 15 factorial different ways to order them. But here's where the division starts. Because I only need to order 7 of them, it's 15 minus 7 factorial. And then I need another 7 factorial because I don't need to, because the order doesn't matter. So if we were going to write this out, this would be 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8, and then the 7 the 8 factorial is actually going to cancel out everything after that, and on the bottom I just have 7 factorial. So if you notice, what I'm doing is I'm canceling this out with the 8 factorial that's left that you notice I did not write on the top. And now 7 times 2 is 14, so those cancel out. We have 6 goes into 12 2 times. 5 times 3 is 15. So I can break 4 down to 2 times 2. And notice that 2 goes into 2, and 2 goes into 10 5 times. So it's one multiplication here. I can do 13 times 11 times 5 times 9. And now I've got 6,435 possible different boys teams. So this goes back to the very first rule of the day. If I have 252 possible different girls teams, and I have 6,435 different boys teams, I have really 2 events taking place. How many total different teams could I get? I'm going to take that 6,435 and I'm going to multiply it by 252. And I'm going to have 1,621,620 different teams. Quite a lot of decisions for our coaches. All right, so I will bring questions to class. I will see you next time.